In this example, we're going to be thinking about union, intersection, and complements, and see how that fits together when we're constructing a Venn diagram. Of the 35 students in my class, 15 are planning to take both Math 113 and Stat 213. 20 are planning to take Stat 213. 3 will not be able to take either class. Draw a Venn diagram to represent the situation. So we do have 35 students for the total. So once we're finished, we should add all the numbers and the total should be 35. 15 students are planning to take both courses. So those two courses are the events. We have math and we have a stat class. So those are the two events. If 15 are planning to take both, then 15 represents the intersection. 20 are planning to take Stat 213. So with Stat, the total is 20. We have 15 already accounted for. So if I take away those 15, that will leave us 5 more students taking Stat. 3 will not be able to take either class. So 3 is the amount that needs to be out in the universe somewhere. And so our total, it says, is 35 students. So with that total of 35, we're going to take away the values that are already listed. So we'll take away 3 from the universe. We'll take away 15 from that intersection. And then we'll take away 5 who are just taking the stat. And that leaves us 12. So I know there are 12 students who are going to be taking math but not taking stat. Complementary events would be something like students who are taking math versus students not taking math. So if we have the event of math, 12 plus 15 would represent the probability of the students who are taking math, but the complement of this event math would be the students not taking math. So if we look at the event for math, I'll just highlight this event. And that way it's more clear as to which numbers are involved, 12 and 15. So any number that's not in the event for math is the complement of math. So we can see those numbers would be 3 and 5. So we have 8 out of the 35 students that would represent the complement of the event math. We will continue our discussion of complements in another section. Now that our Venn diagram is complete, we can find some probabilities relating to this Venn diagram. Example A is the probability that math is in union with statistics. So that means we're looking for students who are taking math or statistics. It's going to the Venn diagram, we're going to add 12 plus 15 plus 5, and that will be divided by the total number of students, and that is 35 students. So when we add our numerator, 15 and 5 make 20, adding 12 more, that would be 32 out of the 35. That decimal is 0.91. So I'll just round to 2 decimal places. Example B says the probability of math intersecting statistics. So this is where we're looking for students taking both math and statistics. That would be the 15. So 15 out of the total, that makes 15 out of 35. And when we divide 15 by 35, we get 0.43. In example C, we have complements being used. So we're looking for the probability of the complement of taking a math course. In other words, not math. So we would find 12 added to 15 makes 27. So out of the total, we need to take 27 away because 27 students are taking math. So 35 minus the 27 divided by the total number of students, which is 35. So that gives us 8 out of 35. And 8 divided by 35 gives us 0.23. In example D, we're looking for the probability that students are not taking statistics, that is the complement of S. So again, we could find how many students are taking statistics, 15 plus 5, and that makes 20. So out of 35 students, we have to take away the 20 that are taking statistics and divide by the total number of students. That will leave us the students that are not in statistics. So not we think of as taking away statistics. So 35 minus 20 would give us 15 out of the 35. And that gives us 0.43. So less than half of the students are not taking statistics. For part E, look inside of the parenthesis first, and then we'll want the complement. We've got math in union with statistics. Well, from part A, we know that math in union with statistics was 32 students. We want the complement of that. So not the 32, we want the leftovers. So that would mean we're starting with a total of 35, but taking away the union of those two courses. So we're taking away 32 out of the total 35. So that looks like it leaves us 3 out of 35. And 3 divided by 35 is 0.09. So just 9% of the students. For part F, we're looking for the probability that students are not in the intersection of math and statistics. In other words, find how many students are taking both math and statistics, and we want all of the other students, not these students. So math and stats would be the 15 students. We want all of the students, but not these. So that means we're starting with all of our students. We're taking away the intersection of 15 divided by the total number of students. So 35 minus 15 would leave us 20 out of the 35. And 20 divided by 35 leaves us 0.57.